What if I told you that ChatGPT doesn't actually understand words? It understands numbers. Somehow, it knows that king is related to queen, Paris is related to France, and puppy is related to dog training. But how? The secret is embeddings, the technology that turns language into a map of meaning. And once you understand embeddings, you'll understand the foundation of modern AI. Every day, AI reads billions of words. But there's a problem. Computers don't understand language the way humans do. To us, king and queen are related, puppy and dog training are connected, but to a computer, words are just text. So how does AI actually understand meaning? The answer is something called embeddings. Embeddings transform language into numbers that create a map of meaning. And that single idea powers modern AI systems, semantic search, vector databases, recommendation engines, and RAG. Imagine every word gets its own location on a giant map. Instead of storing the word itself, we store coordinates that represent its meaning. This process is called embedding generation. We have different word, and each word on giant map gets its own location. Now in between we have mode, L, that convert all the tokens, or car into embedding, S. Now looking at this workflow, you can clearly see how embeddings actually work behind the scenes. Let's start from the left side. Imagine every word in a language gets its own position on a giant map. Not a map of countries or cities, but a map of meaning. On this map, words that talk about similar concepts naturally end up close to one another. For example, we have king, queen grouped together because they all belong to the concept of royalty. Over here, we have dog and cat, which belong to the animal category. And somewhere else on the map, we have physics and mathematics because they share scientific concepts. The important thing to understand is that the computer doesn't create this map manually. Instead, it learns these relationships automatically from massive amounts of text. Every time the model sees words appearing together in similar contexts, it starts learning that those words are somehow related. But computers don't understand words the way humans do. They can't look at the word king and instantly know it's related to royalty. To a computer, words are just pieces of text. So before a computer can place these words on the map, it has to convert them into something it understands. That's where the model comes in. The model takes a word as input and transforms it into a list of numbers. This process is called embedding generation. The output is what we call a vector. A vector is simply a long list of numerical values. For example, the word king might become something like 0.45 minus 0.21, 0.78, 0.11 minus 0.34. And the word queen might become 0.46 minus 0.20, 0.77, 0.10 minus 0.32. Notice how those numbers look very similar. That's because the meanings are very similar. The model has learned that these two words often appear in related contexts. Now, let's compare that with something completely different like mathematics. Its vector might look entirely different because the meaning is different. Once every word has been converted into a vector, those vectors become coordinates inside a massive mathematical space called a semantic space. You can think of semantic space as the giant map shown on the left. Each vector acts like an address on that map. Similar vectors get placed close together. Different vectors get placed far apart. This is why king and queen appear near each other. This is why dog and cat form their own cluster. And this is why mathematics ends up much farther away from royalty-related concepts. In fact, distance becomes a measure of similarity. The closer 2 points are, the more similar their meanings are. The farther apart they are, the less related they are. That's why when you look at these clusters, you're actually looking at groups of ideas that the model believes are related. The denser and more clustered a region becomes, the stronger the semantic relationship between those concepts. And this is exactly what powers modern AI applications. Semantic search uses these embeddings to find documents with similar meaning. Recommendation systems use them to find related products or movies. Vector databases use them to search millions of documents efficiently. And RAG systems use them to retrieve relevant information before generating answers. The most important takeaway is this: embeddings do not capture spelling. They do not care whether words look similar. They capture meaning. The model isn't asking, do these words have the same letters? It's asking, do these words live in the same neighborhood on the map of meaning? And that's the foundation of how modern AI understands language. Let's see this in action. Imagine 3 sentences. The puppy is playing with a tennis ball. Dog training requires patience. And the stock market declined today. We will cover the broad concepts in coming videos. Please like and subscribe if you like it.